For our project, we built a proof of concept of WOCCS, a platform for conducting large-scale, web-oriented citizen computer science. WOCCS allows computer system researchers to leverage the crowd in order to build better systems that are more representative of users' needs than these researchers would otherwise have access to. Our motivation for WOCCS is illustrated in the following example. On the left-hand side is Jetstream, a common synthetic benchmark used to evaluate browser efficiency. However, this is not how users typically use web browsers, as they spend their time interacting with real web pages such as Facebook shown on the right-hand side of the screen. We designed WOCCS to bridge the gap between web-oriented computer systems research and realistic user behavior that is missing from this research. To that end, we designed a system that is able to intercept users' web traffic by proxying their requests to a man-in-the-middle server. The man-in-the-middle server intercepts web traffic and applies instrumentation and analyses specified by researchers. Then, the data corresponding to these analyses is periodically sent to WOCCS servers for researchers to analyze and visualize through a dashboard offline.
We designed WOCCS after app stores. Each study is entered by researchers in a UI. These studies are then displayed in a gallery model to allow users to browse and decide which studies to enroll in. Each study is represented as a thumbnail, featuring a represented image, a title, and a short description. As you can see, from this view, there's a great diversity in studies that WOCCS can support, ranging from HTTP fingerprinting defense to a number of words read on the web tracker. While WOCCS focuses on volunteerism, WOCCS does also support the pay-per-hit model used in other crowdsourcing platforms such as Amazon Mechanical Turk. Users may click on a study to learn more about it. Let's take a look at this JavaScript profiler.
An important aspect of the WOCCS browser plugin is keeping track of browser state. Specifically, the WOCCS browser plugin's job is to be able to track when a user switches between web pages within a tab or other tabs are open within the browser. In this example, we can see that the WOCCS browser plugin is able to detect as the user moves from page to page to page. The WOCCS browser plugin does not enable redirection to the man-in-the-middle interception server until a user has logged in and the plugin has detected that the interception server is online. In the example being shown, the plugin is now talking to the interception server and intercepting traffic. As you can see, the interceptor is intelligent enough to be able to detect different types of content and also instrument relative source files such as HTML and JavaScript files being shown. The JavaScript profiler study counts the number of JavaScript functions that have executed. Periodically, the profiler checks the function invocation count and reports it back to the WOCCS servers. As you can see in the console on the right-hand side of the screen, the profiler's instrumentation output is interspersed with other JavaScript activity within the console. As the user interacts with the page, the function invocation count changes, implying that user interactivity is an important consideration for study of these web pages. After the analysis has taken place, researchers can view and visualize the profiler's activity and also see what resources the user loaded throughout the browsing session.
As previously mentioned, WOCCS also supports the conventional paid hit model. Our experience improves upon this traditional model because it limits the amount of context switching. Rather than having one window open with the directions and another to actually execute the task, we give the user the power to submit the hit from their current window. For example, a hit asks for a name and a phone number, so we simply highlight this data and hit submit. We believe this functionality can greatly improve the workflow of hit-based crowd work.
While we don't have time to go in detail, it is worth noting that WOCCS consists of many pieces of front-end, back-end, and other infrastructure technologies. Here we list out what those components are, and we're happy to discuss them offline.